Okay, so you were given question on set that if set T equal to all the factors of 60 and set M equal to all the multiples of 3 less than 60, that you're to find T union M and T intersection M also to represent the information on the Venn diagram. Okay, with this, let me check what you've done. You want to get the set T supposed to be all the factors of 60. So what are all the factors of 60? Let me check what you have written. You've written 1, 2, you've written 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60, which is 1 times 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. So this is correct, okay? These are all the factors of 60. Now, the next set is all the multiples of 3 less than 60. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42,
42,
45, 48, 51,
54.
54, and 57 because it's less than 60. Good. So that is also correct. Now, once that is done, you now have T union M being the combination of all the T's and all the M. T union M. Let's see.
That's fine.
So T union M being the combination of everything that exists there. So all the factors of 60 and all the multiples of 3 less than 60. So we have 1, 2, 3, 4, 5, 6, 9, 10, 12, 15, 18, 20, then 21, okay, 24, 27, 20, then 30, and 33, 36, 39, 42, 45, okay. I think this is also correct, the combination of the two without having to repeat anyone. So now, T intersection M is what is in T and is in M. So 3, 6, 12, and 30. These numbers are factors of 60 and they are also multiples of 3. Wait, is there any other multiple of 3 that is also a factor of 60? What about 15? 15 is a
Yeah.
multiple, yeah, it's a multiple of 3, right? And it's also a factor of 60. Very good. Do we see any other one? I don't think so. Factor of 60, also multiple of 3. No. So I think it's only 15 that is missing in your answer, okay?
Yeah.
Then that 15 that is here should not be in this place, okay? And should not be in this place. Exactly.
Yeah.
Then it is in the intersection region of the intersection. So 1, 2, 4. Which one is on the left? Is it factors of 60? That's
The
T.
ones on the left is on the factors of 2.
Factors of
I forgot you had
60. Factors of 60, that's T, okay. Then this one
yeah,
is multiples of
60.
3. Multiples of 3, which is M. Okay. Yeah, I think this is a good way, okay?
Mm.
This is a good way. So we can now continue into what is called subset. We have dealt with the meaning of set. We have dealt with the types, like various examples of set, right?
Yeah.
And we have also looked at intersection and union of set. Then, what we did not look at is complement of a set. Before we go into subset, let's look at complement. Let us assume in this same question, you have universal set. If the universal set, which is a combination of all other sets, okay,
Mm.
equal to x, such that x is a number from 1 to 60, okay?
Yeah.
X is 1 to 60. Now, and we have been given all of these terms, these two definitions. We've been given this, okay? That t equal to that and m equal to this other one. Then you've already done it and given us the elements, okay?
Okay.
So you've already given us this, let me bring it down there, this part, which is m and t that you've written out. So you've already given us m and t here. Now they now say find number one, find m union t complement or t union m prime or complement is the same thing, okay? The prime of t and m is what is in the universal that is not in t and m, okay?
Okay.
Let us try to find it. T union m complement will be everything that is in 1 to 60 but is not in t, neither is it in m, okay?
Okay.
So there is 1, there is 2, there is 3, there is 4, 5, 6. Is there 7 in any of them? No.
No.
What about 8? No. What about 9? Yes, it's in one of them. What about 10? It's in the other one, okay?
Okay.
What about 11? No. What about 12? It's present there. 13, not present, okay? 14, not present. 15, present, right?
Yeah.
16, not present. 17, not present in those two sets, okay?
Okay.
18 is not present. 19 is not okay. Is 18 present in one? Yeah. 18 is present in multiples of 3, okay?
Okay.
So 19 is not present. 20 is present in the other one. 21 is also present in multiples of 3. 22, not present. 23, not. What about 24? Yeah, it's present in one.
No percentage.
It's present in multiples of 3, okay?
Okay.
How about 25? Not present. 26? No. 27 is present in multiples of 3. 28, not present in both. 29, not present in both. 30 is present in factors and multiples. So 31, what about 32? Then 33 is present in 1, so 34. 35, 36 is already present in multiples of 3. So 37, are you getting this?
Yeah.
38. What about 39? Is it present in any of the two?
No.
Yeah, it's present in multiples of 3, okay?
Okay.
What about 40? No. 41. 42. But 42 is a multiple of 3, so 43, 44, 45 is a multiple of 3, 46, 47, 48, okay? Okay,
Mhm.
48 is a multiple of 3, so What about 49? And 50, then 50 what? 51,
One.
52, 53. Okay, 51 is a multiple of 3, okay? So it's 52,
Yeah.
53, 54 is a multiple of 3, so 55, 56, okay? Is that
Okay.
clear?
Yeah.
57 is a multiple of 3. What about 58? No. Okay.
Okay.
58 and 59. But 60 is already present, okay?
Okay.
So can you see there are lots of elements from 1 to 60 that are not in the group, right?
Yeah.
So if you want to represent this on a Venn diagram, what I would just do is to draw my Venn diagram. This is really going to be something that's made. So the first circle for the other region and the other circle for maybe the other one. Then we need a large triangle that will contain all of this, okay? I mean, a large rectangle, so something like this, okay?
Yeah.
Now, you're given one. The first one is t, which is factors of 60, and the other one is multiples of 3. So from your workings, we already have 3, 6, 12, 15, and 30, okay?
Mm-hmm.
So we have 3, 6, 12, 15, and 30 as what is common, okay?
Okay.
Then we now want to list all the elements of t, which are factors of 60. So we have 1, 2, 3 is there, 4, 5, 6 is already here, then 7, no. So 7 that is not present in any of them goes here, okay?
Mm-hmm.
Where does it go? In the empty space, in the rectangle, is that clear?
Yeah.
Then 8, is 8 present in any of them? No,
Mm-hmm.
8 also goes here. What about 9? 9 is in multiple of 3, okay? What about 10 is in factor of 60? Is that clear?
Yeah.
11 goes in here. What about 12? It's already there. What about 13 goes here, okay?
Okay.
Are you getting this now? Because I'm going to give you what to do that to look like this, okay?
I'm looking at it.
Yeah, I'm just want to know whether you're getting it. So 13, then what about 14? It goes here. 15 is already here. 16, where does it go? Here. 17 here. What about 18 in multiples of 3, okay?
Okay.
Then 19 goes here. 20 goes where? In factors of 60, okay?
Mm-hmm.
21 goes in multiples of 3, 21. 22 goes in this place, okay? 23 also goes here, right? 24 in multiples of 3. 25, where does it go? Here. 26, where does it go? What about 27? Multiples of 3, okay? 28,
Yeah.
29. What about 30? Is already there. So 31, 32. Then 33 goes in multiples of 3, okay?
Okay.
Then 34, 35, 36, also in multiples of 3. 37, 38. Where does 39 go?
There's no 36. There's no 36.
There's no what?
36.
This is it.
Yeah, but look on top. There's no 36. There's 34, 35, 37. No 36.
Wait. 36 is a multiple of 3, right?
Yeah.
Uh-huh. So it should be here, okay?
Okay.
Do you understand? Now 37, 38. Where do 39 go? 39 goes here. Where does 40 goes? 40 here, okay. 41. 42 is a multiple of 3. Then we have 44, 45, okay. Oh, 45 is also a multiple of 3, okay.
Mm-hmm.
Then 46, 47, 48 is a multiple of 3. Then 49, then 50. 51 is a multiple of 3, okay?
Mm-hmm.
Then 52 here, 53 here, 54 is a multiple of 3. Let me use another color now to identify 54, okay?
Okay.
Then 55, 56, and 57 is a multiple of 3, okay?
Mm-hmm.
Then 58, 59, and 60 comes here as a factor of 60, okay?
Okay.
So all these are what? Factors of 60, right?
Mm-hmm.
While the second one, these are what? They are what? Multiples of what? 3. While all other ones that are in the rectangle, they do not belong to any of the group, they are the complement. Is that clear?
Yeah.
Are you sure this is clear to you?
Let me just look at it.
Okay, so I'm going to give you something to do where you'll be required to represent the complement also in a Venn diagram like this. Is that clear?
Yeah.
You know, this is our Venn diagram where the universal set is 1 to 60, right?
Yeah.
Okay, now, mm, okay, what you're going to do first is to put down these particular details, this page, okay,
Copy it down.
and put it down. So once you're through, I'm going to give you what to do, okay? So this is talking about complements. Is that right?
Mm. Yeah.
Yeah, let me wait. Let me move this one at the bottom. Let me move it up a bit. Yeah, a bit. So these are all the numbers that are in the universal set. I mean the entire data, okay, but they are not in any of the defined set for us, okay?
Okay. Can I copy it down?
Yes, you copy it from this top that says if the universal set is this, okay?
Okay.
If the universal set is X such that X, I want to adjust this a bit before you start so that you can see them at a go instead of having to look for the bottom. Yeah, this one should come up a bit. Okay, I think now it should work. Can you see everything now?
Yeah.
Good. So once you're through, you let me know. So you've submitted this and let's look at the answers if they are correct. The first point there says that A must be all the factors of 48 without putting 48. So what are the factors of 48 without putting 48? We have 1, 2, 3, 4, 6, 8, and that's 4 times 16, 4 times 12, right? Then 3 times 16, then 2 times 24. But we would have put 48, but since it says without 48, then the next one, which is B, and that means 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me check what you've written. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. Okay.
Mm.
Then the next one, which is B, says all multiples of 3 less than 27. So 3, 6, 9, 12, 15, 18, 21, and 24 because they're less than 27. Then it says we should find A union B complement. So A union B complement will be what is in the universal but it's not in A and B. So universal is 1 to 30. So we can see 1, 2, 3, 4. There's no 5 there. So 5. You can see 6. No 7. You can see 8, 9. No 10. 11. There's 12. No 13. No 14. There's 15 somewhere there. There's 16. No 17. No, there's 18. No 19. No 20. But there's 21 there. 22, no. 23 is not present there. 24 is present, and that is about that. So 25, 26, 27, 28, 29, and 30 in the universal. Okay?
Mm.
Are you watching this?
Yeah,
Okay.
I got correct.
Okay. So that means from 5, 7, 10. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 elements. So let me count here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's correct. Okay.
Mm-hmm.
Now, the only thing you did not do is that you did not include all those things, all those complements inside the Venn diagram. Apart from listing them out, you're supposed to put them in the Venn diagram, okay? Is that clear?
Yeah,
If you remember, we did something like that at the top. Can you see that apart from listing them here, they were also in the Venn diagram? Is that clear?
yeah.
And I told you, I said because there's no enough space at the bottom, that's why I put them beside. It's still in the rectangle. So let's go and fix up this. So we need two circles first. A circle and another circle. So probably we have something like this. Then we need to fix in the numbers. What number is in A and B at the same time? We can see 3, right? We can see what again? 6. We can see what else? 12, right?
Mm-hmm.
We can see what again? 24. So that means you're right by picking them here. Then to the left, which is A, and to the right, which is B. So in A, we have 1, 2, 3, 4. So we have 1, 2, there's 3, now 4, 6, 8, 12, 16, 24, 6, then 8, 12, then 16, then 24 is already present there. So that means you're correct. Then on the right side, we have 3, 6, 9, 12, 15. 3, 6, there is 9, 12, then there is 15, 18, 21, 24. 18, 21, then 24. So you're also correct. So the last aspect is to include the remaining details here, okay?
Mm-hmm.
Which is from 1 to 30, 1 to 30. So we have 1, 2, 3, 4, no, 5. They are just the elements here. So 5, 7, 10, 11, 13, 14, 17, 19, 20, 22, 23, 25, 26, 27, 28, 29, and 30. And this is the Venn diagram, okay?
Okay.
So with that, we come to the end of your own class, and I think it's Kenzie that's next, right?
Yeah.
So I'm going to send you, or let me just give you homework before we go, okay?
Okay.
Yeah, the homework you're going to do is something related to what we've been doing, but this time around in a new dimension, okay?
Okay.
So just look at it first. Homework. So if I say, if if the universal set, if the universal set consists of consists of the alphabets A to Z, okay?
Mm-hmm.
The alphabets A to Z, and set A equal all consonants, okay? Or let me just say all vowels, okay? So you know your vowels in English, so all vowels. Then set B equal, I think I'm hearing you now. So set B equals to all the letters of the word international, okay? International. Are you getting that?
Yeah.
So find A union B, then A intersection B, then A union B complement, okay?
Okay.
A union B complement, which is A union B prime. So then the last thing is to represent the information on the Venn diagram. Represent the information on a Venn diagram. Okay? International. So is this clear to you?
Yeah.
Okay, so this is what you're gonna do as homework. I'm gonna send it over to you so you can get your sister from me. I mean your brother from me now. That's Kenzie before your sister.
Okay.
We have here to find the LCM and the HCF is the first one says 32, 48, and 64. Please, I want you to calm down and get set, okay? Now,
Pardon?
it's like you are moving and switching and doing some things. That's why I
I'm
said,
just, I'm just, I'm just
okay,
gonna
okay,
comfortable position.
okay. So, the first thing to do is to know that we're going to divide them, okay? Is
Okay.
that so? We'll be dividing by prime numbers, the numbers that can divide all of these numbers. But because we're looking for HCF and LCM, whenever we're dividing, if we look for the prime numbers that can divide them, like say these ones, we have 2. We can use 2. 2 is the first prime number to use, okay? Is that clear? Can you hear me? Okay, good. So if I use 2 at first, if I use 2, 2 goes in 16, that in 20, in 32, that is 16, okay? And 2 in 48, that is
Okay.
24. while 2 in 64, that is 32, okay?
That's it.
Yeah. Then 2
Okay.
can divide again. 2 in 16, that's 8. 2 in 12, in 24, that's 12. And 2 in 32, that's 16, okay? Then 2 can still divide
Okay.
them. 2 in 8, that's 4. 2 in 12 is 6. And 2 in 16 is 8. I can still use 2. So 2 here is 2, 2 here is 3, and 2 here is 4. Now, no single number can divide all of them again, okay?
Okay.
Otherwise, if any number will divide, it will divide only this and this, will not divide this. Is that clear?
Yes.
So at that spot, I already arrived at my HCF. So HCF of this equal to 2 in 4 places. That is 2 raised to the power 4, okay? And what would this give me? That will give me 16. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Is this clear to you?
Yes.
Good. Then we now proceed to find our LCM. To get our LCM, we now say, okay, let's use 2 again. 2 can divide this, but won't divide this. So this will remain 3, okay?
Okay.
Then I can still use 2. This remains a 1, this remains a 3, while 2 divide this. Then finally I can use 3. This remains the 1, this remains the 1, then 3 here is 1, okay? So that means the LCM now will be the combination of the 2 raised to power 4 and the remaining 3 digits, which is times 2 raised to power 2 again and 3. Okay? Then 2 raised to power 4 is 16,
Okay.
2 squared is 4, and this 3. So what is 16 times 4? That's 64. What is 64 times 3? That would be 192. Okay?
Mm.
Now, the implication of this is that,
Wait, so
can you hear me?
yes.
Okay. The implication of this is that this highest common factor is the biggest number that can divide these three numbers. Okay.
Okay.
Then this LCM, which is lowest common multiple, is the smallest number that the three numbers can divide. Okay. So when we're looking for
Okay.
LCM, we're looking for the lowest number that all the three numbers can divide. So it's always a big number. But when we're looking for highest common factor, it's always a number that is either equal to the smallest among them or smaller than all of them. Okay.
Okay.
Now let's try the second one, which is 24 and 36. Okay.
Okay.
Now for 34 and 24 and 36, we're still going to divide the way we've been divided before. So what I have now is I want to divide with 2. 2 in 24 is 12. 2 in 36 is 18. Then 2 can go again. This is 6 and this is 9. At this spot, 2 cannot go. But there is still a number that can divide the two of them. And that number is 3. Okay.
Okay.
3 here is 2, 5, 3 here is 3. Now at this spot, no number can divide the two of them. So we have reached our highest common factor. Okay.
Okay.
That will be 2 squared times 3. That's 2 times 2, which is 4. 4 times 3, that's 12. That means the biggest number that will divide both of them is 12. Okay. Now for LCM,
Okay.
we have just 2 and 3. So since it's 2 that will divide 2 and 3 that will divide 3, we just combine everything like this as the LCM. Is that clear?
Okay.
Then we have 2 squared times 3 times the remaining 2 and 3. Then this
Wait,
is,
what do you mean by combine?
you said,
What do you mean by combining everything? I didn't really
that is what I'm doing here.
combine.
That is what I'm doing here now. I'm combining them and multiplying them,
Like,
okay?
okay.
Okay. Exactly.
Okay. Yes, sir.
You can see these two and three. These two and three here, they are the two and threes here, okay? So that means the two and three here, I could firstly divide by two and also divide by three. So two will divide only the two and three will divide only. So that's why I just pick them up, okay? Then I have the LCM to be. What is 4 times 3? That's 12. 12 times 2 is what? 24.
God.
And what is 24 times 3? That's 72. Okay? That
Okay.
means the LCM is 72. So I'll give you some time to put this down and I'll give you some to try, okay?
Okay.
So that is finding HCF and LCM. So to get the HCF and the LCM, we want to use the long division method. Like, let me separate the steps, okay?
Okay.
Let me first define HCF. So
Would that
finding,
mean I have to do it again in this method?
no, 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 no. It's just to show you, okay?
Okay.
So finding HCF first for the two questions. So number one, I have 16 and 36. So I'm going to rule the division line, which is 16 here, 36 here. So I'll start from prime number 2. 2 divided 16 gives me 8. 2 divided 36 gives me 18. Okay. Then 2 can still divide them. So 2 divides 8 gives me 4, and 2 divides 18 gives me 9. So since nothing is common again, these 2 cannot divide them. No number is common to the two of them. Then I stop it there for HCF. So the HCF is now 2 times 2, which is 4. But, okay, let's do the second one. Number 2, finding HCF as well. The two numbers. So the first number there is 60, while the second is 45. I have 2 can divide this. That is 30 and 2 here. Oh, 2 can divide, so I can use 3. Is that clear? So 3 here is 20, while 3 here is 15. So 3 can divide again, but 5 can still divide. So 5 here. 5 in 20, that's 4. And 5 here, 3. So no number is common to both of them. Then I stop it there. That gives me my highest common factors. So HCF equal to 3 times 5, which is 15. Now, to find the LCM, I'll follow the same method. I'll follow the same division method. And dividing it simply means I'll I can copy this first step. Okay, can you see this?
Yes.
Okay, fine. So that means I will follow the same method, but I won't stop until I divide until the last digit is being divided by whatever is possible to use in dividing it. Is that clear?
Yes.
So that's why it's almost like the same method. So for number one, finding LCM now this time around. So I'll remove this topic and change it to LCM. And then LCM. So I have 2 can divide 2 can divide. Now 2 can still divide only 4. Okay. Are you following
Okay.
this? Are you listening to this? Because I'm still going to give you one to do
Yes.
as assignment, which you would use this method. So 2 can divide,
Yes.
yeah, 2 can divide only 4. Okay.
Okay.
I won't touch the 9. So 2, yeah, the 9 remains. Then 2 can still divide only the 2. I won't touch the 9, okay?
Okay.
Is that clear?
Yes.
Once nothing can go in the 1 again now, that's when I will now divide with the next one, okay?
Okay.
I'm going to use 3 for 9 because 3 is the number that can divide 9. Is that clear?
Yes.
So I will say 3. If I use 3 now, 3 can't divide anything with 1, so we'll leave the 1, but here is 3. So I can use 3 again. 1 still remains, but 3 divided by 3 gives me 1. Is that clear?
Yes.
So with that, I have gotten more numbers there that will account for the LCM. So the LCM now for this question will now be, how many 2's can you see? That's 4. That's 2 times 2 in 4 places. So then times 3 in 2 places. And that will be 2 raised to the power 4. That is 2 times 2 times 2 times 2. That's 16, okay?
Okay.
And 3 raised to the power 2, that is what? 9, right? That is 3 squared. Is that clear?
Okay.
Good.
Yes.
So that will be 16 times 9. So if I multiply 16 by 9, I have 144, okay?
Okay.
144. So that becomes the LCM. Is this method clear to you now?
Yes.
Now, let us find the LCM for the second one, okay?
Okay.
So we're still going to use the same method, so that's why I want to copy this and just paste on the next page. So if I copy this and paste here, so we're finding LCM of the number. So LCM. Now that nothing can divide again, I will use 2 to divide the 4. Is that clear?
Okay.
And I will not touch the 3. Okay?
Yes.
So 2 divided 4 give me 2. The 3 remain untouched. 2 can still go again. It gives me 1. The 3 remain untouched. Then I will use 3 finally. Okay?
Okay.
Is that clear?
Yes.
Good. So that means if I give you anyone to use this long division method, you should be able to do it. So the LCM now, let's say the LCM now is going to be all of these numbers combined. So how many 2? That is raised power 2. How many 3? That's raised power 2. And how many 5? Only 1. So this is 4 times 9 times 5. What is 4 times 9?
4 times 9,
Yeah, that's 36.
40,
So what's
36.
36 times 5? That's 180. Okay,
Yeah, okay.
so that is how to do it. So I'm going to send you this note. Then
Okay.
let me see the one you're going to try. So let's say you have to find the like homework, which I'll send over. Find the LCM and find the LCM and HCF of the two numbers. So the first one, say you have 24 and 50. Okay. Then number two,
Okay.
let's say you have 18, 28, and 40. Okay.
Okay.
So this will be, you can get your sister for me while I send all this across to you.
Okay.